Hello my fans, you're welcome to my YouTube channel. Today we are going to be taking hot questions in physics. Hot questions that you cannot escape in physics exams. If you can solve these questions, then be rest assured you are ready for your exams. Alright, so I'll be writing the questions on the board and we'll be solving them together. Alright, let's look at this question. Question 1 says, a train with an initial velocity of 20 meters per second is subjected to a uniform deceleration of 2 meters per second square. The time required to bring the train to a complete halt is dash, and you're given options. Fans, anytime you see a question like this, the first thing you have to do is quickly write out the parameters you are given. Quickly do that. So from the question, a train with an initial velocity of, now we're giving initial velocity as what? 20 meters per second, right? Initial velocity is represented as u. So u is what we use to represent initial velocity. So u is equal to 20 meters per second. They say it's subjected to a uniform deceleration of 2 meters per second square. Now, acceleration and deceleration, they are opposites. Acceleration, you are moving forward. Deceleration, you are retarding. Deceleration, you are reducing your speed. Acceleration, you are increasing your speed. Do you understand? So now, deceleration, we still use A to represent deceleration, but deceleration is always negative. So the value of deceleration is always what? It's always negative. So anytime you see deceleration, always put a negative sign there. So A will be equal to, that's deceleration, will be equal to 2 meters per second square, right? But since it is not acceleration but deceleration, we'll say minus 2 meters per second square. Good. Now the time required to bring the train to a complete halt is dash. We're asked to calculate the time. But now you agree with me, if the car started with an initial velocity of 20 meters per second square, for the car to stop completely, it means the final velocity will be 0, right? Because the car stopped completely. So for the car to stop completely, it means the final velocity, which is represented as v, will be equal to 0. Because they said the car will stop completely. So the final velocity will be 0. So if the final velocity is 0, the car is no longer moving. Now we are asked to calculate t. If you look at all these very well, you can check that, you can observe that it is the equation of motion we use, one of the equations of motion. And in this case, which equation of motion will be relevant here? We have u, we have a, we have t, we have v. Have you seen an equation like this? V equal to u plus at. This is the first equation of motion. V equal to u plus at, where v is the final velocity, u is the initial velocity, a is acceleration, and t is time. Now we just substitute and we continue. So v, we have v as 0, u, we have u as 20, plus a, we have a as minus. Please don't make that mistake of writing just 2. We have minus 2 because they say deceleration. So here we have minus 2 times t. So t is what we are looking for. So if I continue to solve, I'll be having 0 equal to 20. If I open the bracket, plus minus, I'll have minus 2t. Right? So if I cross over, if I collect like them and cross over this one to this side, I'll be having, if minus is crossing the equality sign, it's the what? Plus, right? So you'll be having 2t equal to 20. Now, to make t the subject of the formula, you divide both sides by the coefficient of t, meaning you divide both sides by 2. So it means 2 will cancel 2 here, and t will be equal to 20 divided by 2 is what? 10. And since it's time, and other things were in meter per seconds, the time will be 10 seconds. That's option what? Option A. You see how simple it is, right? See how simple it is. Once you understand it, you can solve it very fast. Alright, my fans, let's look at the second question. Said a person approaches a plane mirror at 5 meters per second. How fast do they approach the mirror image? Anytime you see a question like this, my fans, the first thing you do is to smile because it's a bonus question. Now, they said a person approaches a plane mirror. Let's look at this thing as a mirror. Let's say this is a mirror. And this is a person walking towards the plane mirror. You agree with me that if this person is here, it means the image will be formed somewhere here too. So if this is the person, let's say this is the object and this is the mirror and this is the mirror image. If you've seen mirror before, that thing you used to use and view yourself, you agree with me that the distance between you and the mirror is always the same thing as the distance between the image and the mirror. So the object distance is always equal to the image distance, right? It means as you are walking towards this mirror, your image will be walking towards the mirror, right? Until you get very close to the mirror like this, your image, you can even kiss your image on the mirror because people are close now. So as you are walking far from the mirror, the image will be walking far from the mirror. As you are walking towards the mirror, the image will be walking towards the mirror. Now the question says, a person approaches a plane mirror at 5 meters per second. That is, the person is walking at 5 meters per second. 5 meters per second walking. How fast do they approach the mirror image? How fast is this person approaching the mirror image? Now, this is it. This person is walking to this point at 5 meters per second. Is walking towards this. And you agree with me that if this one is walking at 5 meters per second, the image will still be walking at 5 meters per second towards this. So since this one is coming and this one is not static, is not standing in a place, this one is also moving, you see that this person here, the object, will approach the mirror image 2 times faster. Now check. Okay, now check. The object, the person moving, will reach the mirror, and this one is still coming. This one is moving at 5 meters per second. This one is moving at 5 meters per second. So since this one is moving at 5 meters per second and this one is moving at 5 meters per second, you see that it will be 2 times faster. 2 times faster. So because of that, anytime you see a equation like this, the object will always approach the mirror 2 times faster. So since the person is moving at 5 meters per second square, how fast do they approach each other? They approach each other at 2 times 5, which is 10 meters per second. The 2 here is because we are looking at the object and the image. So the answer to this question is actually 10 meters per second. So that's the answer to that question. This one is coming here, this one is coming here. So the time they will meet each other becomes small. Do we understand that? All right. All right, my fans. Let's look at question 3. A satellite revolving around the Earth is kept on its orbit by dash. A. Centrifugal forces only. B. Centripetal forces only. C. Centripetal and frictional forces. D. Centripetal and centrifugal forces. So before we look at the answer to this question, let me explain briefly what centripetal and centrifugal force is talking about. Just look at this. You have a ball and you have a rope attached to the ball, and you hold this rope and you are swinging the ball in a circular path. You are swinging the ball in a circular path. Now this rope here is trying to keep the ball towards the center of the circle. As you are swinging it like that, it is the rope, the force in the rope that is holding the ball, towards the center of the circle. That force that acts towards the center of a circular path is called centripetal force. So centripetal is towards the center, while centrifugal force is can be seen as the ball itself that want to fly away. So centrifugal force is acting away from the center. Now if you look at a satellite like the moon, a satellite is kept, a satellite revolves around the Earth and is kept in its orbit. Now you agree, you've known about gravitational force, and gravitational force is a kind of a pull towards the center of the Earth. That gravitational force is what is keeping this satellite in its orbit, and that gravitational force, since it's trying to pull the satellite towards the center of the orbit, towards the center of the Earth, Remember, centripetal force is towards the center. Centrifugal force is away. So the force that keeps this revolving in its orbit is centripetal forces only. So the answer is centripetal forces only, because centrifugal force is kind of moving it away and it's a perceived force. But centripetal force, it's kind of putting its force acting towards the center of the circle, of the circular part. That is the answer to this question. So centripetal forces only is the answer to this question. Okay, my fans, let's look at question 4. Question 4 says, how much energy is required by a 40-watt light bulb running for 10 minutes? And we're given the options. Now, anytime you want to solve something like this, the first thing you have to do is quickly write out the parameters you were given. That will make you to stay organized and know what to do. So how much energy is required? First of all, we are asked to calculate energy. So energy we don't know. It's required by 40-watt light bulb. And watt here, you agree with me that watt here is a unit of what? Power, right? So we're giving power as 40 watts. Running for 10 minutes. We're giving time as 10 minutes. Now, to calculate this, first of all, the time is given in minutes. You have to convert it to seconds. So converting this to seconds now, 10 minutes to seconds, this will be 10 times 60. Because 60 seconds make 1 minute, right? So you multiply by 60 to get it in seconds. So 10 times 60 is what? 600 seconds. Now, you agree with me that from the fundamental formula, we know that power is equal to work done over time taken. Power, that's power, work done over time taken. Now, energy is same thing as work done. Energy is same thing as work done. So the formula here is the same thing. So we want to make work done or energy the subject of the formula here. So the work done or energy is equal to, or let me use E here, energy, since that's what we were asked. So, but just know work done and energy here is the same thing. So making E the subject of the formula, what do? We cross multiply, right? So we'll be having E equal to power times time. So energy is equal to, power was given as what? 40, right? Times the time is what? 600 seconds. So 600 seconds. That means that energy will be equal to 4 times 6 will give us what? 24, right? Then we'll add our 3 zeros. 1, 2, 3. Now the unit here is watt second, but watt second is same thing as joules. So the answer is 24,000 joules. And where is it? Option B. That is our answer. Hope you are following. Please, if you've not subscribed to this channel, please just click on the subscribe button down there. Click on the subscribe button now. Click on the subscribe button, because more videos will be uploaded that you will gain from. So please click on the subscribe button and share this video so as many as you can share, as many platforms as you can share. So subscribe and click on the bell notification so that you'll be notified anytime I post a new video. You'll be notified that I've posted. Go and learn. All right, so can we continue? All right, my friends, let's look at question 5. Heat losses to the surrounding are possible through the following except dash. A. Conduction, B. Convection, C. Radiation, and D. Expansion. Now, conduction, we are looking at heat transfer through either a solid or a liquid. That's conduction. Anything that can allow heat or electricity to pass through them, we say they are conductors, right? So that's that. Convection can be seen in liquids. Radiation can be seen in gases. Expansion, we're looking at stretching of a particular material. So which is not, they say heat losses to the surrounding are possible through the following except. So which one of these will not permit heat loss? The answer is simply D. Because conduction, heat can be lost through conduction, convection, and radiation. So these are the 3 methods of heat losses: conduction, solid, majorly, and liquid; convection in liquid; and radiation in gases. So these are the three methods. These are the three main ways of heat loss to the surrounding, and not expansion. Expansion is not there. So this is the correct answer to that question. Alright, once you're making progress, you're making good progress. If you're not subscribed, please subscribe now. Question 6. Which of the following is not a luminous object? Before you can even answer it, first you have to know what a luminous object is. A luminous object is any object that emits its own light, that gives out its own light, that have light to give out its own light. So that's a luminous object. Now A says the moon. Sorry, A says the sun, B says the moon, C says light candle, D star. So which one is not a luminous object? Which one does not have its own light? The sun have its own light that it gives out. What of the moon? What of light candle? Light candle have its own light now that it gives out. Star has its own light that it gives out. But the moon is not a luminous object, because that light we see from the moon is not produced by the moon. That light we see is actually a reflection from the sun. So the moon does not produce its own light. Instead, it reflects light from the sun. Do you understand? So the moon does not have its own light. Instead, it reflects light from the sun. That is why the moon is not a luminous object. The moon is not a luminous object. All right, my friends, let's look at question 7. Calculate the apparent weight loss of a man weighing 70 kilograms in an elevator moving downwards with an acceleration of 1.5 meter per second square. So just like I always say, write the parameters given. We're given the mass of the man to be 70 kilograms, and we're given the acceleration of the man, the acceleration downwards, as 1.5 meter per second square. And you know, force of gravity is always there. Acceleration due to gravity is always 10 meter per second square. Now we're asked to calculate the apparent weight loss. The apparent weight loss. Now, apparent weight loss apparent means something that is not real, something that is not actual. Apparent weight loss is equal to the apparent weight. I'm using W for weight. Apparent weight minus the actual weight. So if you want to calculate the apparent weight loss, you just look at the apparent weight in the elevator. That's not the real weight of the man, minus the actual weight of the man. So now, before we do this, let's calculate apparent weight and calculate actual weight before we can subtract. So let me start with actual weight. Actual weight. The actual weight of the man is equal to, remember we're giving mass, right? And weight is relative to gravity. So the actual weight of the man is 70 times force of gravity. So actual weight of the man is equal to 70 times 10, which is what? 700 Newton. This is the actual weight of the man. The actual weight, that is the real weight of the man. Weight is relative to gravity. That is why my weight when I'm downstairs is different from my weight if I climb to the mountain. Weight is relative to force of gravity. That is why we always multiply the mass by force of gravity to get our weight. Do you get that? Now, that's the actual weight. Now, the apparent weight. Apparent weight is given as mass into G plus A. Let me explain. The apparent weight is just multiply the mass times gravity plus force of gravity plus the acceleration. Now, actual weight is just the mass times the force of gravity, acceleration due to gravity. While apparent weight is the mass times acceleration due to gravity plus the acceleration of the man in that elevator. So this will give us the mass. We know the mass was given as 70 into G, acceleration due to gravity is 10, plus A, which is acceleration of the man, we're given as 1.5. So this will be 70 into 10 plus 1.5 will give us what? This will give us 11.5. So if you open this, 70 times 11.5 will give us what? Plus 805 Newton. So we've gotten the apparent weight and we've gotten the actual weight. So apparent weight loss, let me use apparent weight loss. Please check what I'm doing because of this space. Apparent weight loss is equal to, remember apparent weight loss is apparent weight minus actual weight. So apparent weight now is 805 minus actual weight 700. So if we do 805 minus 700, we'll be having what? 105 Newton. So the apparent weight of the man is 105 Newton, and that's our option C. So anytime you ask yourself something like this, just calculate your actual weight. The actual weight is just the mass times acceleration due to gravity. So the mass times 10 will give you the apparent weight. Will give you the actual weight. They can give you acceleration due to gravity as 9.8. You still use that. Then the apparent weight is just the mass times G plus A. Then apparent weight loss is just apparent weight minus the actual weight. That will give you your answer. Alright fans, let's look at this one. The dimension for power is dash. The dimension for power is that, and options we are given. Anytime you hear dimension, what should come to your mind is the three fundamental quantities: mass, length, and time. So it's always given as MLT, and it's a bonus question. MLT, mass, length, and time. But how is it arranged? Now, the dimension for power. Now let's start. Power. You agree with me that power is work done over time taken, right? Work done over time taken. That's power. And you know, work done is force times distance, right? We still have our time here. So force times distance, so this work, and we have time here. And you still agree with me that force is mass times acceleration, right? So mass times acceleration times distance all over t. You can write this distance here, or you can write it in all, no problem. You are still correct. So the next thing is power is equal to mass. We've gotten mass. Remember what we want to do, we want to get MLT, mass, length, and time. We've gotten mass, we've gotten time. This is distance. Distance is length. So this is L. But A now, we've not resolved that. So this is mass times A is acceleration, right? And you agree with me that acceleration is changing velocity all over time, right? So velocity over time. Let me use capital letter T. And times distance over time. Good. Now, we still have V here. So I can still resolve this to say mass is equal to, you agree with me that velocity is distance over time, right? So mass times velocity is distance over time. So only this one up here is distance over time, but we still have over time here. So over time. Do you get? So this S over T is the same thing as velocity, then over time, then times S over T. At this point, we just make everything balance and we are done. So power is equal to mass times. Now this same thing here, if I have S over T divide by T, it's same thing as saying S over T times 1 over T. Anytime you want to change division to time, just take 1 over what is here. So I just change this division to times by taking 1 over this. So we'll be having S over T times T is what? T square. So everything here is S over T square. Hope you understand. So everything here, this stuff here is S over T square. This one here. So here I have S over T square. Then times S over T. Now if I multiply everything here, I'll be having M times S is what? S square, right? Over T square times T will give me what? T cube, T raised to power 3. Because of laws of indices. This is raised to power 1. This same thing as raised to power 1. So since the bases are the same, you pick 1. Then you add the powers. 2 plus 1, 3. Now this is same thing as saying, you know, this S represents distance, and distance is for length, right? Length is for distance. So I'll be changing this S to L because distance is length. So I'll be having M L square all over T cube. So basically this is our answer. But if I want to bring this T, if I don't want to do over T cube, I want to bring it here, then you have to make it negative. So if I'm bringing this one up, I'll be having ml square, then t minus 3. So if I'm bringing this one from down up here, it becomes minus 3. So this is our dimension for power, and that's option what? That's option A. That's option A. So you see, it's very simple. It's actually very simple. Now, this is where I will stop this particular video. If you've learned something from this video, I pray you succeed in your exam you're preparing for. You succeed in your exam and you score very, very high. That's my prayer for you. If you believe you will succeed in your exam, type in the comment section, I will succeed. I will succeed. So type in the comment section, I will succeed. If you've not subscribed, subscribe to this channel and go to my channel and watch my other videos. And if you have any question, feel free to drop it in the comment section. I will always respond to your questions. My name is Excellent Simplified.